Yeah, good morning, everyone. So as Derek mentioned, Jeff and I have taken on the role that Marcus did an amazing job at the last 3 years. So I guess we want to start out by saying thank you to Marcus for solid maintainership the last 3 years. Yeah, let's give Marcus a round of applause. He's not here, but he's definitely listening in. So early this year, we were tapped to step up and do the day-to-day maintenance and kind of code-based release management. And we want to step through what that involves and what our view is for the future, and what some of these processes are that makes the code base more easy to maintain, more stable, and helps us out as a community. All right, so hand it over to Jeff, who was co-maintaining here.
And we're dividing the briefing up by length, not so much by what we do, because we do really work on this together. Yeah. And if you were to ask who the maintainer is for GNU Radio, you can kind of point to some people, but really it's a bunch of people. And somebody has to be in charge of pushing the button that says merge. So that's why we're called the maintainers, but certainly a lot of people participate in the process. And we'll talk about some ways that you can too. So one thing that we're trying here, this is nothing we invented, but just not the way GNU Radio worked in the past, is maintaining multiple branches at once and doing some aggressive backporting. And this came out of a problem we were having that, first of all, we would put out releases seldomly. And so if the API changed, it was pretty painful, but people had probably forgotten about the last one and weren't around to, or the same people weren't around to complain about it when we did it again. And that worked, but it's a trade-off. It takes effort, it takes people to maintain multiple branches. But we were wondering what would happen if we tried to maintain a stable branch that got the features people wanted in it, so that we could extend the period. We could get more changes in while extending the period between API changes. And that's what we're really trying now. So, and as you can see, I don't really read my own slides. I just talk and then look down once in a while and figure out what I was supposed to have said. So keeping the branches consistent makes maintenance easier. One thing that we found right off was we were trying to maintain multiple branches, and if you tried to backport something and all the code around it had changed, then that didn't work so well. So the first thought was only backport exactly the things we need, but it was kind of obvious that if all of the includes change in master and you try to backport something, then it doesn't tend to work so much. And then the quarterly or approximately quarterly cadence, we've been able to keep up with that. That's sort of arbitrary, but that came out of, we missed the Debian window. And so we're still paying for that a little bit. We probably could have gotten 3.9 into Debian, except that our calendars didn't sync up. This doesn't mean calendars are going to sync up, but if we release something quarterly, there's always something for somebody to pick up. And there are so many downstreams we have now that there's always somebody who wants to pick up something. So the master branch is our dev. Nothing's really changed there. And then eventually, there get to be enough differences that we can't backport stuff. So there are some things in master that we can't backport to 3.9 without breaking the API or causing people some pain. And eventually, we'll decide that becomes too much and we need a new maintenance release. So here's some questions that I would ask, and originally we put this slide in here. Here, fill in the answers to these, but realizing we had no answers, we just changed the briefing to make it look like we meant it to be a rhetorical question. So how many we keep active, that partly depends on how people are using it and what kind of effort we can support. 3.8 right now is not getting a huge number of changes, but it is getting some. So 3.8 will probably be around for a while since that's what's in Debian right now. So anybody who has input on this, let us know. By the way, I'm Willcode or Willcode 4 online, so anybody who's been doing dev has probably run into Morman and Willcode.
That's us.
That's us. So we try to hide behind the monikers, but they made us get up here. Okay.
Yeah, so just something to keep in mind, after the 3.10 release, which will be coming soon, we plan on renaming the master branch based on what people are generally doing in other communities and industry, and mainly also to reflect our use of this branch. So we use this generally as a development branch. It is not the trunk. It is not the thing that we keep stable all the time. So we do plan on renaming this to something to reflect that.
Josh got that one because, you know, in case somebody threw something. It causes some pain when you need change the name, but we see the need to change the name.
And that's why we're waiting till after the next release.
So for anybody who's wondering, we are committed to changing the name for all the good reasons, but we're gonna try not to break things for everybody in the process. Okay, a little bit about the process. Now, if you're a dev, you've run into this, but the typical way of learning about it is you submit a PR and we say, no, that's not how it's done. And then gradually, you know, within a month, you're a trained PR submitter and you're an expert and you can help the next person. But so for anybody who comes back and watches this, here's just a little bit about how it works. We use Git source code control. Everybody probably knows that. That works great. We use GitHub for our hosting, and we do all our work via pull requests and issues. We also use the CI infrastructure, which is built into GitHub, and that's very helpful because we can say, yes, this built and it passed all of our tests, and we are getting to have a pretty good test suite that runs automatically. We do not do direct commits, so that's a project rule that everything has to be traceable. It goes through a PR and gets committed to the branch via merging the PR. And also we do a linear history, so we don't do the thing that looks like a zipper where you merge in, you know, make a change, merge it in, make a change, merge it in. So everything is rebased and merged on top of the Git history. The PR checks, the pull request checks that are automatically done whenever you submit one via the CI system, we look for the contributor sign off. So when you hit the signed by in your favorite Git client or type it in manually, because it really doesn't matter, what you're saying is that I own this code. And I don't know if we're talking about licensing anywhere else in this, but anyways, you're saying that I own this code, or whoever owns this code told me I could do this. That, you know, this is all above board. Here, you can have it. That's basically what it says. It's not the prior handing over your license to the Free Software Foundation or anything like that currently. But there is a check for that, and your PR will get bounced if you don't put that in. So that's the first thing that people find out if they don't know about that. Their PR bounces. And then formatting, and to encourage people to use Clang format and make nice formatted code, the checks won't go any further if your code does not pass formatting. And then it builds and it tests on multiple targets. The actual targets are different per branch, but that's like the Debian and Ubuntu and Fedora and CentOS, I think are most of them. Several people, including Martin, while we've been sitting here, has been making changes, improvements to make sure that stuff gets tested better against more recent containers, more recent targets. And these are containers. So we talk about having GNU Radio in containers sometimes. It already is. For our CI system, it's just custom designed, only what we need for CI. So, and you can go further with that. So once a PR gets in, and maybe even before that, we have a review by experienced devs. And this can be anybody. This can be anybody who just signs up and wants to talk about a PR. If you're an expert, chime in, because we're not always the experts, and whoever's the current expert on this might be busy doing something else. So it's kind of all equal. And then we look for some approvals before something can go into master. Everything goes to master first. There are some exceptions, but the rule is that commits go to master and then we backport them. This process can take time. Don't get frustrated because there are a relatively small number of people running through this whole process. So if one or two people are off on vacation, then everything can slow down. Or if GNU Radio is all having a conference, then everything slows down. And one important thing, this is true, indecision. We sometimes somebody's got a great idea, but we're just thinking, what's that going to affect? And we don't have the expertise. So we may stall on a PR just because, I don't know. Okay, so for backporting, we want to consider PRs that are useful. If it's something like a spelling correction, well, we did just backport a spelling correction because it was visible to the end user. But if it's a comment spelling correction, maybe that's not so useful to backport. If it's a major bug, that's useful. But also, it's got to cause no harm, and we are mostly concerned with the API, so that if you rebuild your code, it will work. I have something else on this later, but we're not quite as concerned about the ABI running your code that was compiled 3 years ago and having it work. So then either you, the PR submitter, or we go through them frequently and kind of say that one would look good, can tag in GitHub with the backport 3.x. Right now it's 3.8 or 3.9. And that says we intend to backport, or we think this is a good idea. The author should have some input on that. If you know the releases, put in there whether you think it should be backport, even if you don't tag it. And then if a PR is pretty much push button, then that's great. So if your PR backports cleanly to 3.9, then all we have to do is set up some cross references, and that's great. We can actually do those, the backports, and it's almost easier because if you set up a backport, then I have to come along and say, are these two the same? So I actually look at the diffs, diff the diffs, and if the diffs are different, then I have to ask you what's the diff. So if they're the same, then just set it up, tag it, we'll take care of it. If there are differences, and we've had a bunch of these where the backport has to be done a different way because things have changed, dependencies have changed, versions have changed, then if the author can help, that would be great. And then once things are backported, we retag them with a ported to, just to show it that has been ported. That doesn't necessarily mean it's been merged, but that means the port has been done. So in 3.9, we're trying to track master as closely as possible for the reasons I said earlier. But we're not changing things in the build system unless we think that they're really clean. So anything to do with CMake, and we're not changing any dependencies because if somebody's built against a certain version of a dependency, we actually don't know what version all the downstreams are using. So we got to be really careful with that. The API, as I said, has to be backward compatible, and we try not to break existing flow graphs. Once you get into GRC, it gets just a little bit harder to make sure of that, but that's the intent. Hopefully we're not routinely breaking flow graphs, or you just delete a block and put it back and everything's good. For the main 3.8, very limited changes. And this is for stability, but it's also because of developer resources. We just, we don't have somebody who's dedicated to 3.8. And if we decide that this is going to be an LTS brand, maybe we actually do need to do that. But right now we're just de-emphasizing doing the changes on that one a little bit. Bug fixes will get back. New blocks, fortunately in GNU Radio, if you add a new block, it's often very clean. And so we can backport major new functionality because it doesn't affect anything else. Performance improvements that get backported are generally due to a bug fix. So I don't think we'll backport too many performance improvements that are just like a little processing gain in there. GRC, the backporting is a little different. We've been a little more aggressive with that all the way to 3.8 because that's a separate application. And as long as it doesn't break anything, it seems like it's nice to have the user experience the same. A good example of that is there was some great work to automatically detect a stale cache file, and because people were running 3.8 and then 3.9 and then master, and nothing would work because all the GRC definitions were different. And so porting back all the way to 3.8 or having GRC detect what version of the cache file is there really helped out with that. Release. So how do you get releases? You can get them in the GitHub release area. We put them there whenever we officially tag one. You can clone on a branch if you want. The numbering, we use the semantic versioning, and our version of semantic versioning says that the last digit is just a patch. It has no effect on anything other than maybe it fixes a bug. The second to last number changes the ABI, so your program, if you run that program from 3 years ago that you compiled, may not run against today's version. The second digit in is the API, so if that changes, you're not guaranteed that your program will compile. You may have to do some work. And if the first number changes, then the Earth is rotating the other way at the moment. And so Josh is going to talk about the next time that's going to happen in a few minutes. If you look at the semantic versioning with libc, you might notice that everything is backwards from the way we do it, because libc wants you to be able to run that program you compiled 5 years ago, and then the developer being able to recompile it is they're considered slightly less important. And so I don't know if there's a right way. For libraries, they are doing it the right way. But GNU Radio is both a library and an application, and we chose to do it a little different way. Anything that we put out there is signed. And so the project has GNU PGP keys, pick your way of saying it. The signatures are put up in the release area, and the keys are also available there. I've put them up on OpenPGP and pgp.mit.edu, but I haven't had any luck getting it back from MIT. Querying it, they're just pretty busy. But anyways, it just seemed like a good idea to have those signed. The only difference there with the past is in the past we've had a developer go off and create a key, and here it's owned by the project, not a developer. Fedora asked us on 3.8 to continue what we had done before and include Vulk. So we released that with and without Vulk. In 3.9 and forward, Vulk is a totally external project. In 3.8, it was a submodule. So that's just a minor detail. I don't know if anybody else relies on it being there, but their tooling relied on that already being checked out. Some example downstreams, and before I forget it, Phil just mentioned that Yocto is now doing 3.9, and he's testing that. But we've got your typical distros, Debian, Ubuntu, Fedora, variety of environments, Conda we heard about, and there are probably others like that. We've got PyBombs, and we talked about maybe cooperating a little more between PyBombs and Conda. Containers, we use them for CI. There are other users that have created them out there. Windows installers, I don't know much about the Mac stuff, but there's a Mac installer too, or do they use the PPAs?
I think they have a homebrew. Someone has maintained a homebrew channel on there.
And then there are lots of things we don't know about, which is a fun part of one of these projects, is we don't even know how it's distributed. So the team is trying to keep the PRQ manageable. And we've been doing a pretty good job keeping it down to 20, 30 sometimes when we're not paying attention.
Keep it on one page. That's the goal. Yeah,
keep it on one page, and more importantly, keep it in our minds. So it's not like when did this PR come in? So we're just trying to be responsive on it. You can help out a little bit by cleaning up draft PRs if they stay draft for a while, and resubmit them later. And so after this, I'm going to go delete my draft PR that's been up there for a month and a half that I don't know what to do with.
So unreviewed PRs is probably the biggest bottleneck to getting things upstream. Anyone that has some technical knowledge of the area that these PRs are submitted in, please get in there, review them, take a look, try it out. So it's not always a line by line review that's needed on everything. Like, we need someone to do that. But a lot of times we need people to try it out in these different scenarios. So if you have a chance, get in and try out these PRs. Helps us out big time.
And then keeping your PR up to date is important for two reasons. One, if it gets old, then it may not apply. And the second, less obvious reason is that we watch on Matrix the GitHub actions. And when you update your PR, it jogs our memory. It says, oh, this person's still out there and they're interested. I don't know, I use it that way at least. I see all the updates come through. When you put in both PRs and commits, please put in the module : and then a good short explanation, and that helps a lot. Just quickly, the releases we put out this year, we started with 3.9 and then put out maintenance releases of both 3.9 and 3.8 a couple of times. And there are some new RCs out right now. You can find all this on the release page. So why would you want to go to 3.9? Most of the new features only get ported to 3.9. That's the user idea. The developer reason, once you get past the PyBind 11 learning curve, and thanks to Josh especially for getting all of this working, it's just better, and that's hard to quantify. I don't know. Can you explain more about why it's better?
Swig can easily turn into a black hole where you can't get things working in Swig. It's a different language, and there's not much transparency as to what's going on. PyBind 11, the code is C++. It's right there. It's not a new language to learn. And yeah, once those bindings are working, the error messages are better if you mess something up. It's much easier to trace. So it's definitely the path forward for us, and in industry as well. So.
And then developers tend to like the latest stuff, so they're going to be working on 3.9. If you, as a user, you move to 3.9, you're going to get your questions answered faster and all that good stuff that comes with staying on the latest release. Why wouldn't you want to do that, though? For developers, you do have to spend a day or so figuring out PyBind 11, getting everything ported, and the typical way to do this, if you can, is you start over, copy your code in. That's one of the common ways to do it. For users, sort of related, your OOTs may not have been ported yet, so you need some out of tree thing. Although if you need one out of tree from 3.8 and one from 3.9, then you go harass the one who owns the 3.8 one. Just wanted to go over one feature that we put in master and then backported to 3.9. That people may not know a whole lot about. The SOAPy SDR framework from the Pothos project is a driver abstraction that has no driver-specific code in it. And this is useful because we can put that in our framework and we don't have to update that anytime RTL changes or HackRF changes or anything like that, because those modules are completely separate and they're dynamically loaded. The original version of this was done by the people at LibreSpace. Thank you very much. We took that, ported it to 3.9, refactored it a bit to make it more like some of the other modules that we have, and then wrapped that in GNU Radio blocks a little differently. But LibreSpace showed us how to do it. We re-architected it. Like I said, no driver-specific code. We had a little chicken and egg problem when we went to, I think it was 3.9 originally, where GROsmo SDR, which is great, wasn't ported to 3.9, and so users were left without any way to hook up to their SDR for a while. And that was one of the things that motivated us to do this. You'll still have GROsmo SDR out there, it's great, but now there's a separate framework where as long as the driver module, the SOAPy driver modules match the version, the ABI version that's built into GNU Radio, and that doesn't change much, then you're good. Your same binaries will work. It's also just a little more modern. When they designed SOAPy SDR, they took into account some more modern SDRs than were around when GROsmo SDR was designed a very long time ago. The architecture of it, there's the GNU Radio layer of this, where we've got just a source and a sink, and we'll include the headers from SOAPy SDR. And then there are the YAML files. So when I said that there's nothing hardware specific, I slightly lied, because there is a generic SOAPy source and SOAPy sink YAML file for GRC, but they're unmaintainable because there's like ifs for every single field for every single SDR. So we put some skeleton ones in there. You might find them slightly lacking for a bunch of specific SDRs, but as people try them out and say I could really use additional parameters, we can add that. And writing YAML is something a user really can do. If you just look at the files and add a couple of parameters, you may be able to figure that out and hopefully contribute it back. Then there's SOAPy SDR. Underneath that are the SOAPy modules. If you don't like the way something is done in the RTL SOAPy module, go over to the Pothosware site and offer to change it there. We don't maintain those, but Josh Bloom is very happy if people will come over and help with any improvements. And they've got a bunch of them. And then the drivers below, the quote vendor drivers below that, whatever that means, the modules are linked to.
All right, cool, thanks, Jeff. So I want to talk a little bit about the upcoming features that are going to be released in our next major release. So 3.10 is coming up. So we originally had planned for 3.10 to be released around the time of GRCon. But with the aggressive backporting that Jeff has done, most of the features and bug fixes have gone into the 3.9 and 3.8 releases, so it wasn't quite as pressing to push something out the door. So, we're waiting for some critical mass of features that are not able to be backported because, once we go to the next major release, it's going to break things, and we try to get that done once and done, one shot. So, the transition from 3.9 to 3.10 should not be nearly as bad as was from 3.7 to 3.8 or 3.8 to 3.9. There's some API breaks, but it should be possible for you to support in your out-of-tree module both 3.9 and 3.10 at the same time, with depending on what those API breaks are. So in the 3.10 release, there are some exciting things that are sitting there in the master branch that have not been backported. The first of these is GRPDU. So this is a set of tools, they were mentioned in some of the talks yesterday, upstream from Sandia National Labs, and this is the ability to handle packetized data and the tools around that. And so there's a talk tomorrow from Jacob Gilbert is doing a short talk tomorrow about this, and he'll go into detail about what's been upstreamed, what hasn't. And there was things in the other blocks, in the other modules that handle packetized data. And so a lot of those have been moved around to work within this GRPDU module. So that's why this hasn't been backported to the maintenance releases. GRIIO, so this is another out-of-tree module that Analog Devices has maintained. So this is support for all of their IIO infrastructure. And we saw the talk yesterday, not later this week, that was yesterday. And so there's sources and sinks generically to handle IIO devices, but then specific flavors so that you can easily natively hook up, say, your Pluto SDR or your FM comms board. So we have a bit of work to do here to get this ready for release in a way that it's going to be maintainable going forward. But that is there in the master branch, and if you're interested in helping out with that effort, please jump in and try it out and find things and help us out there. So Derek mentioned yesterday GRSigMF. So this was SigMF, again, the signal metadata format is a way to capture signals along with the data that describes these signals. And there is an out-of-tree module managed by SkySafe that we do plan on upstreaming. We've had discussions about this. Whether it makes it into 3.10 or not, depending on the timing of it, still TBD. But that will be a great addition to the tree. So one of the other features that Marcus has been working heavily on here is getting rid of log4CPP as a dependence. So this is a very unwieldy dependency on a lot of older distributions. It's hard to find it through the CMake and build with log4CPP. So getting rid of it's the right decision. And it also, along the way, we're using spdlog is the replacement for log4CPP. And so spdlog comes along with lib format, which will allow us also to get rid of more boost. So we can get rid of boost format and continue to deboostify the code base. So thanks to Marcus for pushing this one along. And then this one I'm really excited about, and David Sorber, who's presenting in just a little bit, is pushing. There's a PR sitting there for, I don't want to go into too much detail because he's going to talk a lot better than I can about this, but the ability to get rid of the extra copy in going between accelerators and restructuring that data movement. And so, it's very, I wouldn't say difficult, but it's non-optimal right now when you want to interface GNU Radio with an accelerator device, whether that's a GPU or an FPGA board. You have to go in between the GNU Radio buffers and the device buffers, and there's an extra copy, and those buffers, you don't have the double buffer mechanism necessarily on these accelerators. And so, David has some great work there that will be released in 3.10 as an experimental feature. So after his talk and we get some review on this PR, we're hoping to get that in. All right, so apart from the code base and the code features, there's other things that we want to improve upon from a maintenance perspective. One is our ability to have packaged releases available for everybody. So Maitland does an awesome job there. Ryan Volz does an awesome job in packaging things, but especially in your distribution packaging, if you're using Ubuntu 18.04 and you say apt install GNU Radio, it's going to be some much older version of GNU Radio. It's going to be maybe, I think it's a 3.8 release candidate that is there in 18.04 because of this. We missed the release window, as Jeff mentioned before. So we do keep up a PPA, and every time Jeff makes releases of these maintenance branches, package these up, get these in place. There's usually a lag. So improving this process, automating this process is something we'd really like to do. So if anyone's interested in that, please let me know. It needs a champion, and it needs better tooling, better scripts. And Conda is a way to get things running. If you're willing to take that step into the Conda world, and Conda is a great answer also to getting things running on Windows at this point. So there's different tools, different things out there. So which is the easiest to maintain? Definitely looking for insight and feedback there. Our CI infrastructure. So we always want to have better test coverage. We want to be able to trust the CI. We want to know that when that thing lights up green, that this PR is good to merge. We have some flakiness with our QA tests, so those are always good. If you have an idea as to why one of those is not working, those are good to figure out, because we don't want to just disable QA tests just so that it passes most of the time, because we do have a good set of QA tests. But there's other things that maybe we should be testing that we're not, like all of the GRC examples. So Hakan has put together a feature where it will automatically step through and test all the GRC examples, but it always fails because not all of our GRC examples compile correctly. So that's something that it would be good to get tied into the CI in a solid way. And another thing that would be really awesome is having flow graphs with real data. So Ron, Dr. Mpeg, has put together some of that for the DTV stuff, some short files, and it runs it through, and you get real data in, and you're able to validate the real data out. So doing that more across the board would be a good thing for our CI. And the other thing is, we have a good number of Windows users, and Conda is the current solution for getting things running on Windows. And there are some managed Windows packaging, but being able to have a place where you can just double click like you would any other Windows program, it's a tough problem. But that's something we'd like to be able to have in the future. So GR 4.0. Why are we talking about GR 4.0 when we haven't even gotten through release 3.10? Well, this is a big effort that's kind of going on the side to do a lot of these things that people have been thinking about for a long time. So back in 2019 in Huntsville, Marcus presented what's the next big thing. And this involves a lot of really structural changes to GNU Radio. What we call the scheduler, it's not so much a scheduler. It's a bunch of threads, and we let the operating system do what it does, right? So what he proposed, and this was based on a paper published with Bastian Bossel, if you're able to lump multiple blocks within each worker thread, tie those to the CPUs, and then also have a single actor model where you're able to handle the stream data and the message data in the same consistent way, this will get us a long way structurally to be able to have higher performance. And that was shown in that paper, and that that you can get big performance gains, 2, 3x on just that, running multiple blocks within each worker thread. So we're working on this as a separate effort, and we'll get into, this is the new Sched repository. You probably see it kicked around quite a bit. So what is our vision for GNU Radio 4.0? So we talked about this last year, and this hasn't really changed. What we really want is three major things. We want modularity. So we can't solve the scheduler problem for everyone. Different applications, different boards, different platforms have different requirements. And so having that scheduler piece, decoupled from the code, it's not just the GNU Radio scheduler. This is how the runtime interacts with a scheduler. That's going to be the key for us to supporting a lot of things going forward. And that ties into heterogeneous architectures. There's a lot of different accelerators, a lot of different platforms. You'll see from DeepWave later this week has a platform, with embedded GPUs and FPGAs. How do you get that all to work nice together? You have to have seamless integration in with GNU Radio and these accelerators. And then also looking forward, we'd also like to be able to do distributed DSP. How can we have flow graphs that span multiple nodes? How do you have things running on different processing elements? Could you have a distributed environment of different nodes, each running a piece of the flow graph all executed from a central place, harnessing all those resources? So this is the vision for GNU Radio 4.0, and how do you bring this all together in a way that still feels like GNU Radio and still is easy for the primary user to, press a button and run a flow graph, but take advantage of the power of all these different platforms. So this is a slide I stole from Bastion, and as far as the GNU Radio GPP scheduler, right now on the left you see that our approach right now is a thread per block, and then you throw it all to the operating system. It does what it does, and depending on the scenario, it works well. And you take a performance hit with all the thread synchronization mechanisms. The better approach, and again, this was outlined in his paper in 2019, is if you can intelligently map these blocks to worker threads that are pinned to cores, then you can do some intelligent scheduling at the top. You can actually have this scheduler piece and not just rely on the underlying operating system to manage everything. So that's the basic idea. But bigger picture also, this is one way that we would want to handle these types of flow graphs. We also want the scheduler to be modular. So that top scheduler piece, that's something that should be able to be swapped out with an out-of-tree scheduler. So what is GNU Sched? So GNU Sched is the place where we're prototyping these ideas that we hope will become the basis for a GR 4.0 runtime. So this is where we're looking to do this modularity, heterogeneity, distributed processing, and also we've expanded this vision a bit, which we'll get to in the next couple of slides. So the thing with GNU Sched is rather than taking the GNU Radio code base and starting to do surgery in there and adding things into the GNU Radio code base, we took a clean slate approach. Let's start from scratch. What do we want this thing to look like? And then let's build up and add in things from GNU Radio as we go. So we're slowly building up a usable block library into this with some of the concepts. So beyond these main vision goals, beyond the modularity and stuff, we're able to do things that we wouldn't be able to do normally in the GNU Radio code base. We want to seriously clean up the APIs. Because GNU Radio has been so tightly coupled to its own scheduler, there's a lot of things in the block APIs, for example, that really only refer to the one way of scheduling that GNU Radio currently does. Here's my output stream. How many samples do I need? And then what's all these hints that I need for you to be able to do that calculation? Another thing is there's got to be a way to have a better developer experience for people making GR blocks, because the more people that are using GNU Radio, The more active that development, the more DSP blocks and features can be upstreamed. I know plenty of people that love to do signal processing, have the ability to release things open source, but oh man, I got to do this in GNU Radio. I have to go through mod tool and make blocks and stuff. They'd rather do it in some other framework sometimes because it's easier. So we want to get rid of those barriers and make GNU Radio the place where it's easy to get to insert signal processing here. Another thing with our signal processing library, right now we have all this amazing, amazing set of blocks, but right now you can't directly call the work function. That's something we want to work on. Have the actual signal processing where you can call the block kernel, have that a separable thing so you can wrap that in other ways, use it in other frameworks. Native thread safety, our blocks vary greatly as to how thread safe, how they're handling mutexes. And then also something we're going to hear about later today from John Saleh is replacing the PMTs with something better. And there's, yeah, we'll let him get into that, but there's a lot of interesting work going on there. So these are all just things that they're not the main goals of GR 4.0, but things along the way. Now, if we're going from scratch, we can address these things and come up with a solid design. So what do I mean when I say a better developer experience? So let's take a case study. You want to create a block with GR mod tool. It's great, it works. You know, I'm able to get in there, have all my template, I insert signal processing here. Oh man, but now I need to go back and add a parameter to the make function. So now you have to go through all these steps and handle and change everything in all these different places. So this is just one example of, this is something we can improve and, you know, look at ways of automating this process. Definitely looking for feedback here and ways we can make this a more streamlined process. So how do you get involved in GR 4.0? So first, there's a workshop on Thursday, and we're going to go more into the detail, take a look at the code, see what the current state of events is with the new Sketch project. And we'll also, it'll be an open discussion about future plans of new Sketch. How do we want to, you know, what do we want to focus on? Second, we have a scheduler working group. So there's a core group of folks that have been consistent in meeting, you know, every 1 or 2 months we've gotten together, sometimes more often, sometimes less. And we'll talk about that on the next slide. Third, fork the repo, try out the code base, see what you think of the experience of running the current prototypes. And that's the best way to get involved, try it out. So every so often we have what we call a scheduler working group. So this is a group of people. I'd rattle off names, but I miss a lot of folks. You know, Jeff is obviously heavily involved. Bastian Blossel is really the leader of this group. He's the brain trust here. And we started this around GRCon last year. We had a breakout session, and after that session, we kind of kept going. And we have a chat room here, pound scheduler on the matrix chat, and then there's a mailing list, which it's a little less active. Mainly on the chat is where things get communicated. So we've covered a lot of topics. You see the topics there, I won't go through all of them. I'll give one example here for PMTs. Like John, who's having a talk later today, you know, had ideas about how PMTs can be improved. And so he presented to this group, you know, a brain dump of all his ideas. We discuss it, the ideas get refined, and, you know, when there's a champion for a particular topic, this type of format works really great. You know, going forward, we plan on continuing this group. So if you have an idea for something you'd like to see improved in GNU Radio, the topics have been very widely varied and diverse. And so, you know, present something to the group, we'll schedule it. People show up, we usually do it around lunchtime, Eastern Standard Time. And yeah, so this has been a very productive group that, you know, hopefully more folks will get involved in. So how do we get to GR 4.0? What does that look like? So if we look at this chart, the top the top line is our current dev branch, master branch. The first thing that we're focused on is getting the work that Blacklinks and David Sorber here have done with this GNU Radio ng-schedule, better data movement, custom buffers, get that merged in before the 3.10 release. After that, perhaps there'll be a 3.11 release, depending on what rolls in. There's no roadmap, no list of features for a release after 3.10. But in parallel down here, we have the new schedule prototypes. So is it at a minimum viable product? It can run flow graphs now. We can show some various different things. I would think that would be a minimum viable product, but there's a lot of gaps there between what new schedule can do and what GNU Radio can do. So we need to fill in that gaps before we can even think about getting this up into mainline GNU Radio. So there is a so that's planning that needs to take place, but this is the path that I'm hoping for, that new schedule will eventually move up into the mainline GNU Radio development code. All right, and I believe that is all of our slides. So do we have any questions here? I believe I'll give one of these microphones to Sam.
Yeah, one more thing. Thanks to all the devs and people who participate in this whole process. You might ask, why would you want to be a maintainer on this? And it's because you get in the middle of these world-class engineers and people with all kinds of cool ideas. Somebody will drop by who's an expert on C++ modernization, or somebody who wrote the test suite for MPEG, or so you just get to see these people all the time. So thank you to you guys. Great crowd. Questions there? Anybody online? We are on time then.
All right.
Thank you.